Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will go through permeability of stratified soil deposits. In layered soil, each layer may be homogeneous and isotropic, but when flow through entire deposit is considered, the average permeability of deposit has to be known. This will vary with the direction of flow relative to the bedding plane. The average permeability parallel to the bedding plane will be greater than that perpendicular to the bedding plane. Let Z1, Z2 till Zn be the thickness of layers of permeabilities K1, K2 till Kn. For flow parallel to bedding plane, the hydraulic gradient I will be same for all the layers. The total discharge Q through the deposit is equal to sum of discharges through individual layers, that is Q1 plus Q2 till Qn. So, we get the equation Q equal to Q1 plus Q2 plus Q3 till Qn. Let this be equation number 1. Kx is equal to average permeability parallel to the bedding plane. From Darcy's law, Q equal to Kx I into A. A is equal to Z into thickness perpendicular to plane of the figure. So, let us consider thickness perpendicular to plane of figure be equal to 1. So, A will be equal to Z into 1. So, Q1 will be K1 I into Z1 considering x equal to 1. Similarly, for x equal to 2, Q2 will be K2 I Z2 and so on. So, finally, Qn can be written as Kn I Zn. So, substitute values of Q, Q1, Q2 and Qn in the equation number 1. We get Kxiz equal to K1Iz1 plus K2Iz2 till Knizn. And finally, Kx will be equal to K1Z1 plus K2Z2 till Knzn divided by Z, where Z is summation of Z1, Z2 till Zn. Now we will find out average permeability perpendicular to the bedding plane. For flow perpendicular to bedding plane, discharge Q will be same for all the layers. So, total head loss is equal to sum of head losses in individual layers. H will be equal to H1 plus H2 till Hn. Let this be equation number 1. And Kz is equal to average permeability perpendicular to bedding plane. So, here Z is the total thickness of the soil deposit and Z1, Z2 till Zn are the thickness of the soil layers. And velocity of flow is perpendicular to the layers of soil deposits being considered. From Darcy's law, V is equal to Kz into I, where I is hydraulic gradient which is equal to H divided by Z. So, the equation for H will be Vz divided by Kz. For individual layers, H1 will be equal to Vz1 divided by K1, H2 equal to Vz2 divided by K2 and Hn will be equal to Vzn divided by Kn. Substitute that in equation number 1, we get Vz divided by Kz which is equal to Vz1 divided by K1 plus Vz2 divided by K2 till Vzn divided by Kn. So, finally, we get Kz equal to Z divided by Z1 divided by K1 plus Z2 divided by K2 till Zn divided by Kn. Now, we will solve a problem. Calculate the coefficient of permeability of a soil sample 6 cm in height and 50 square centimeter in cross sectional area if a quantity of water equal to 430 centimeter cube passed down in 10 minutes under an effective constant head of 40 centimeter. On oven drying, the test specimen weighed 4.98 Newton. Take G is equal to 2.65. Find the seepage velocity of water during the test. Given data are length of specimen equal to 6 cm. In mm it will be 60. Area of cross section A equal to 5000 square mm, quantity of water Q is equal to 430 cc, and time of flow T is equal to 600 second. Constant head H is equal to 400 mm. With these values, we need to find out what is K and what is Vs. So to find K, we have formula QL divided by A into H into T. Q is 430 into 1000, L is 60 whole divided by area is 5000, H is 400 and T is 600. With this we get K in mm per second as 0.0215. To find Vs, we have formula V divided by N. So discharge velocity V is equal to Q divided by A, that is Q divided by A into T. Q is 430 into 1000, area is 5000 and T is 600. With this we get V as 0.143 mm per second. V can also be found out using formula K into H divided by L. Now we need to find out what is porosity. N is equal to E divided by 1 plus E. E is equal to G into gamma W divided by gamma D minus 1. Gamma D is WD divided by V, where volume V is equal to A into L, area is 5000 and L is 60. So we get volume equal to 3 into 10 raised to 5 mm cube. Gamma D is equal to WD, that is 4.98 divided by volume, that is 3 into 10 raised to 5, with which we get gamma D as 1.66 into 10 raised to minus 5 Newton per mm cube. Once we substitute all these values, we get voids ratio E as 0.57. Now we can find porosity N equal to 0.57 whole divided by 1 plus E, that is 0.57. So N is equal to 0.36. Substitute in the equation to find seepage velocity. Vs is equal to V, that is 0.143 divided by porosity, that is 0.36, which will be equal to 0.397 mm per second. Now we will find the horizontal and vertical permeabilities of soil deposit consisting of 3 layers, 150, 180 and 200 cm thick, with permeabilities 10 raised to minus 5, 10 raised to minus 7 and 10 raised to minus 9 meter per second. Average permeability parallel to the bedding plane can be given by formula Kx equal to K1Z1 plus K2Z2 plus K3Z3 whole divided by Z1 plus Z2 plus Z3. So Kx is equal to 10 raised to minus 5 into 1.5 plus 10 raised to minus 7 into 1.8 plus 10 raised to minus 9 into 2 whole divided by 1.5 plus 1.8 plus 2. So Kx is equal to 0.286 into 10 raised to minus 5 meter per second. Average permeability perpendicular to the bedding plane is given by formula Kz equal to Z whole divided by Z1 divided by K1 plus Z2 divided by K2 till Zn divided by Kn. Z is Z1 plus Z2 plus Z3. So it is 1.5 plus 1.8 plus 2 divided by Z1 is 1.5 divided by K1 is 10 raised to minus 5 plus Z2 is 1.8 and K2 is 10 raised to minus 7 plus Z3 is 2 divided by K3, that is 10 raised to minus 9. With this we get Kz equal to 0.00026 into 10 raised to minus 5 meter per second. In a falling head permeability test, the length and area of cross section of soil specimen are 0.17 meter and 21.8 into 10 raised to minus 4 square meter respectively. Find the time required for the head to drop from 0.25 meter to 0.1 meter. The area of cross section of standpipe is 2 into 10 raised to minus 4 square meter. The sample has 3 layers with permeabilities 3 into 10 raised to minus 5 meter per second for first 0.06 meter, 4 into 10 raised to minus 5 meter per second for second 0.06 meter and 6 into 10 raised to minus 5 meter per second for third 0.05 meter thickness. Assume the flow is taking place perpendicular to the bedding plane. Length of specimen L equal to 0.17 meter, A equal to 21.8 into 10 raised to minus 4 square meter, H1 equal to 0.25 meter, H2 is 0.1 meter. A is 2 into 10 raised to minus 4 square meter. K1 equal to 3 into 10 raised to minus 5 meter per second. Z1 is 0.06 meter. K2 is 4 into 10 raised to minus 5 meter per second. Z2 is 0.06 meter. K3 is 6 into 10 raised to minus 5 meter per second, and Z3 is 0.05 meter. Now we'll have to find out T. So to find T, the formula is AL divided by AK log of H1 divided by H2. So first we will find out what is Kz. So Kz is equal to Z whole divided by Z1 divided by K1 plus Z2 divided by K2 till Zn divided by Kn. Z is Z1 plus Z2 plus Z3, that is 0.06 plus 0.06 plus 0.05 divided by Z1 is 0.06, K1 is 3 into 10 raised to minus 5, Z2 is 0.06 and K2 is 4 into 10 raised to minus 5, Z3 is 0.05 divided by K3 is 6 into 10 raised to minus 5. So Kz is equal to 3.92 into 10 raised to minus 5 meter per second. So substitute to find the value of T. T is equal to area, that is 2 into 10 raised to minus 4 into L, that is 0.17. Then area of soil sample 21.8 into 10 raised to minus 4 into K, that is 3.92 into 10 raised to minus 5. Log of H1 is 0.25 and H2 is 0.1, with which we get T is equal to 365 seconds. Importance of permeability in geotechnical design. Permeability influences the rate of settlement of a saturated soil under load. The design of earth dams is based on permeability of soil. The stability of slopes and retaining structures are affected by permeability of soil. Filters made of soils are designed based on their permeability. Use of permeability. It is used to estimate the quantity of underground seepage and seepage through body of earth dams. To solve problems involving pumping seepage, water from construction, excavation and settlement of foundations. To perform stability analysis of earth structures and earth retaining walls subjected to seepage forces. Thank you.